Yeah, and then next is the question, how can we compare time series? And with time series, well, it's more or less the same with like with sequences, but with time series there are actually two general ways to compare time series on a kind of meta level. Yeah, and I try to motivate then that from some examples here. So example similar categories for time series data. So we, for example, want to identify companies with similar patterns of growth. Yeah, and maybe it's enough for us to see if the companies. So we have a company as a query, and we want to find all those companies that have a similar pattern of growth. And maybe we are absolutely satisfied if this pattern is just a sub-pattern. So the similar pattern is not over the whole time, but just for a subsequence, yeah, for a sub period of time stamps. Yeah? We may be interested in determined products with similar selling patterns. Once again, the same here. Maybe interesting only to see if some products are just similar over a short period of time and not over the entire time series. Yeah? Discover stocks with similar movements in stock prices. The same. Find if a musical score is similar to one of the copyrighted scores. Here again, we might want to compare the entire musical score, but also to compare only subsequences of the musical score. Yeah. So, and you see, I overemphasize this this subsequence thing. So. Basically, on the meta level, we have two different types of similarity notions or queries. Yeah, we have a whole matching as before, where time series are usually assumed to have to all have the same length, and we really match each full time series to all the other full time series. Yeah, so similarity is matching the full time series. Yeah. And the second thing about the subsequence is that time series may have different length, of course, and similarity would just be finding the subsequence that has the best match. Yeah. So, for example, we have a portion of the music of a musical score, and we want to look in our musical score database if we have a plagiat. Yeah. If we have one copyrighted musical score that has where this part which we just query right now is already there somewhere, yeah, and then we have a short period of the musical score which is violating some copyright. So in that case, we just want to find the subsequence that has the best match. Yeah. And here is the illustration of this concept. So the illustration of the whole matching here is, so we have a query, can also be just a template, yeah, of the query. And then we want to match the whole template or the whole query against the entire time series in the database. Yeah, so this is our database consisting of those time series here. And in that case, for example, 06 for some reasons seem to be the best match. Yeah. Seems to be the best match for this one here. Yeah, but we compare an entire query or query template against all the entire time series. Yeah, and now in the subsequence similarity or subsequence matching, this is a little different. So again, we have a query, potentially template, or a real query time series, which is much shorter than the original time series in the database. Yeah, so this is the template. This is just one time series from the database, and now we want to find the best match of the query Q with O. Yeah, so here, for example, this subsequence seems to be the best match of the template with the entire thing here. So this determines the similarity between the whole object, the whole time series O, and the query Q. Yeah, so the whole thing is not aligned to the query is not aligned to the entire time series anymore, but just to some subsequence, and we need to find the best subsequence or the best matching subsequence, and that determines the similarity of the particular or the corresponding time series with the query. You know? And there is a very popular variant. So if the length of the best matching subsequence is fixed to some n, then we can use a sliding window as a pre-processing step, a sliding window of width n, to go over each of the time series in the database, and so to say blow up the space or the object space. So in order or instead of just storing the entire time series, we can just partition those time series in the database into all those small sliding window chunks of width n. So that we store this one here and the next sliding window and so on and so on. So we just move a sliding window from left to right, and we store for each sliding window position, we store the subsequence in the database instead of the whole thing. And then it comes down to a whole matching scenario, obviously. But this only obviously works if the length of the subsequence is fixed. So if the query template, for example, is always the same, has always the same length, then we can do that. So and that brings us to the overview of how can we really measure the similarity between time series. So there are a lot of similarity measures for time series. So here just the probably most popular things here. Minkowski distances, which is basically a cleaning distance. We will have a look on that. Uniform time warping. Then we will have, so this is Minkowski for time series which have different length. So dynamic time warping is let's say the similar thing like the edit distance for sequences. Longest common subsequence can also be done for time series. And then we have all those edit distance variants here on real sequences with real penalty. We can also have shape-based distances and stuff like that. So we will focus on the first four here, talk about that, I think, in the next podcast.